And welcome to another problem. Today we're going to be doing 2d3 move zeros. So, given an integer array nums, we want to move all zeros to the end of it while maintaining the relative order of those non-zero elements. And we should do this in place without making a copy of the array. Now, an idea for how to do this is what we can do is have two pointers, one starting from the left and one starting from the right. What we can do, both starting at the left. But what we can do is we can have one pointer always consistently moving forward no matter what. The other pointer will only move forward, will only want to move if we encounter a zero, then we want to swap the left and the right and then move it forward. So what I mean by that is, like, let's say 0 and 0, we start off with this one ahead, right? So we start off here, and then we go and check to see this one, 1. Well, if we have a 1 here, we can check, and if this is a non-zero number, and this is a 0 number, then we can swap the left and the right, and we can make this 1 and 0. And then we can go ahead and increment the left one forward. Now, we can try this again. This moves forward, this moves forward. Oh, it's a non-zero number. We swap this with 3, and then this becomes a 0. And then we move this forward. Oh, it's a 0. And this is forward, we swap this with 12, and then this becomes 0 over here. And then at the very end, you'll notice that we have it fully ordered while maintaining the relative order of the non-zero elements. So, if that makes sense, I'll go ahead and begin coding this up now, where we have a left and a right, which is equal to 0 and 1. And while let's do this, where we have L is equal to 0, and then 4 right in range length of nums, so at the very end it'll be terminated. What we can do is check to see if the nums at the left pointer is equal to 0 and the nums at the right pointer is not equal to 0, then we want to swap it. So nums left, nums right is equal to nums right, nums left. And then, otherwise, if nums left is equal to 0, then, if nums, as soon as nums left is not equal to 0, then we want to move it forward. So L plus equals 1. And, yeah. If the left is equal to a non-zero number, we just want to keep continually moving forward until it does encounter a 0. So this makes sense over here. Yeah. So for this one, we swap it, and at the very end, we can go ahead and return the length of the not length of the numbers. We should go ahead and return at the very end the nums array. So, just a quick check, same thing, that's our logic. Well, we start off with the left pointer is 0, the right pointer, we can move it forward, so you don't actually need to start at 1 ahead, you can just start at 0, and then it'll go ahead and check to see if this criteria is valid, it swaps it forward, otherwise it moves the left pointer forward by 1. If it's not equal to 0, then you return it. Let's go ahead and run this and see if there's any mistakes. Okay, we're accepted. Nice, and looks good. Time complexity for this one is linear. It's O of n because just traversing through the elements in the array, you don't have to loop through it over and over again. Space complexity of this one is O of 1 because you're not actually storing anything in the memory. So, yeah, there we go. Thanks for watching.